Hi students, I am Praveen Sebastian Paul. In this lecture we are discussing the KMap or Karnaugh map. In the previous set of lectures we have simplified the Boolean functions using Boolean postulates and theorems. It's a time consuming process and we have to rewrite the simplified expression each after each step. To overcome this difficulty, Karnaugh introduced a method for simplification of Boolean function in an easy way. This method is known as Karnaugh map method or simply KMap method. It is a graphical method which consists of 2 raised to n cells for n set of variables, and the adjacent cells are differed only in a single bit position. So as we said, it is a simplified way for solving the Boolean functions without using Boolean postulates or Boolean theorems. So my dear students, the KMap varies from 2 variable to 5 variable. These are the common set of KMap solutions. The KMap method is most suitable for minimizing the Boolean functions of 2 variables, 3 variables, 4 variables and 5 variables. Now let us discuss about the KMap for 2 to 5 variables one by one. So firstly we are considering the 2 variable KMap. The number of cells in 2 variable KMap is 4. So as we said, we are dealing with the 2 variables. The total number of cells depend upon 2 raised to n. Here the n is 2. Therefore total number of cells available is 2 raised to n, that is 2 raised to 2, which is equal to 4 cells. So there is only one possibility of grouping the 4 adjacent minterms. The possible combinations of grouping 2 adjacent minterms are m0, m1 or m2, m3 or m0, m2 and finally m1, m3. So these are the 4 possible combinations available in this 2 variable KMap. So as we can see in this figure, there are 2 possibilities for representing these 2 variables using this KMap solution. So in the upcoming set of lectures, we will discuss how to solve a function or a Boolean function using this KMap. This is just an introduction for how to represent a combination of 2 variables. So as we know, 2 variables in this example, we are considering the variables y and z. The most possible combinations are 0, 0, 0, 1, 1, 0 and 1, 1. And the 0, 0 is represented in min term using m suffix 0, m0, and 0, 1 is represented by m1, 1, 0 is represented by m2 and 1, 1 is represented by m3. So next we are discussing the 3 variable KMap. The number of cell in 3 variable KMap is 8. This is because 2 raised to 3, which gives 8 different cells, and the figure shows how these 3 variables are represented in KMap. There is only one possibility of grouping 8 adjacent minterms. The possible combination of grouping 4 adjacent minterms are m0, m1, m3, m2, then m4, m5, m7, m6. Another one is m0, m1, m4, m5. Next one is m1, m3, m5, m7. Another one is m3, m2, m7, m6. And finally m2, m0, m6, m4. The possible combination of grouping 2 adjacent minterms are m0, m1, m1, m3, m3, m2, m2, m0, m4, m5, m5, m7, m7, m6, m6, m4, m0, m4, m1, m5, m3, m7 and finally m2, m6. If x is equal to 0, then 3 variable KMap becomes 2 variable KMap. So there arises a question why we are combining or grouping these terms. So this we will discuss in the upcoming lecture. That is the rules for grouping the KMap. So this grouping is made in order to solve the given Boolean function, and there are different rules for grouping that will be discussed in the upcoming lecture. So in the case of 4 variable KMap, the number of cells in the 4 variable KMap is 16. This is because we are taking 2 raised to n, that is 2 raised to 4 and 2 raised to 4 will give 16. So 16 will be the total number of cells available in 4 variable KMap. And this figure shows how we can represent the 4 variable in a KMap solution. There is only one possibility of grouping 16 adjacent minterms. Let R1, R2, R3 and R4 represent the minterms of the first row, second row, third row and the fourth row respectively. Similarly, C1, C2, C3, C4 represent the minterms of the first column, second, third and fourth column respectively. The possible combinations of grouping 8 adjacent minterms are R1, R2, R2, R3, R3, R4, R4, R1, then C1, C2, C2, C3, C3, C4 and C4, C1. If W is equal to 0, then 4 variable KMap become 3 variable KMap. While we are considering a 5 variable KMap, the possibility of representing a 5 variable KMap is as shown in this figure. 2 raised to 5 set of cells, that is total number of 32 cells. There is only one possibility of grouping this 32 adjacent minterms, and there are two possibility of grouping 16 adjacent minterms. And if v is equal to 0, then 5 variable KMap becomes 4 variable KMap. In all the above discussed KMap, we used exclusively the minterm notation. Similarly, we can use the exclusively max term notation also. If we are considering the minimization of Boolean functions using KMap, let us consider the combination of input for which Boolean function is 1. Then we will get the Boolean function which is in standard sum of product form after simplifying the KMap. Similarly, if we are considering the combination of input by which the Boolean function is 0, then we will get the Boolean function which is a standard product of sums form after simplifying the KMap. Following these rules of simplifying KMap in order to get standard SOP form, the different rules include: select the respective KMap based upon the number of variables present in the Boolean function. Secondly, if the Boolean function is given as sum of minterm form, then place the 1 at the respective minterm cell in the KMap. And there also, if the Boolean function is given as sum of product form, then place the 1 in all possible cell of KMap for which the given product term are valid. Thirdly, check for the possibilities of grouping maximum number of adjacent ones. It should be the power of 2. Start from the highest power of 2 and up to least power of 2. Highest power is equal to the number of variables considered in the KMap, and the least power is always 0. Then each group will give either a literal or one product term. It is known as a prime implicant. The prime implicant is said to be essential prime implicant if at least a single one is not covered with any other grouping, but only that grouping covers. And finally, note down all the prime implicants and essential prime implicants. The simplified Boolean function contains all essential prime implicants and only the required prime implicants. Here, while considering this set of rules, there are two nots to be considered. The knot number 1 is, if the output are not defined for some combination of inputs, then those output values will be represented with don't care symbol X. That means we can consider them as either 0 or 1. Secondly, if the don't care term also present, then place don't care X in the respective cell of the KMap. Consider only the don't cares X that are helpful for grouping the maximum number of adjacent ones. In those cases, treat the don't care value as 1. So my dear students, this lecture is just an introduction to the KMap or Karnaugh map, which is used for the solution of Boolean function without considering the Boolean postulates or Boolean theorems. So my dear students, kindly go through this assignment question. The assignment question is write about the Karnaugh map or KMap. So my dear students, in the upcoming lecture we will discuss the KMap for SOP, that is Karnaugh map for sum of products. So dear students, see you soon. Until then, goodbye, thank you, and all the best.